All right, you guys, it is the review, so I'm going to go through this with you, and then remember you can pause it anytime you want. You can rewind it and just go. So I'm just going to go through it. If you have a question, you can always email me or text me. Say, okay, so 9, 10. So the test is just like this, So let's take a look at number 1. So I want you to graph the function, graph that. I want you to graph the parent function, which I'll do in, let's do it in purple. Well, no, let's do it a different color, purple. Let's do graph the function as parent function purple, okay? Yeah, we'll just do both, okay? All right, so here we go. Let's do number 1. XY axis. Number 1 should be easy. Okay, again, if I get going too fast, just pause it. So, the regular function, we're going to start at +1. And then I'm going to go down 3, 1, 2, 3, and over 4, 1, 2, 3, 4. And again, I can go 3, 4, 1, 2, 3, 4. And that is our regular function there. Okay, now, the parent function is just simply going to be, I'll do that in red. Yeah, I'll do it in red. Y equals x is the parent function, so y equals x. So you got to graph both tomorrow, both, all right? Parent function goes like that, and that's my y equals x, okay? That's my parent function. Number 2 is a parabola because of the x squared. So let me graph that. Okay, xy axis. Again, if I get going too fast, you can just pause it. I just want to get it on tape. So it's going to be a parabola. I know that for sure. The vertex is, remember, opposite, opposite, opposite. +1, 5. So I'm going to go 1, 1, 2, 3, 4, 5. There it is. It is going to be upside down, so it's going to be more like that. And then it's going to be twice as tall. So instead of doing my 1, 1, because 1 squared is 1, I'm going to go 1, 2. Instead of 1, 2, 4, because 2 squared, 2 times 2. Instead of 2, 4, I'm going to go 2. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. I know my parabola is symmetrical with the vertex, so I'm going to have another point here, fold it over, and another point here. Again, you can also put this on Desmos and graph these on Desmos. That's not a bad idea either. That will always work. Ooh, lousy looking. Now, that's our function. The parent function is a regular y equals x squared, which is our regular function, over 1, 1 squared is 1, over 1, 2, 2 squared, 2 times 2 is 4, 1, 2, 3, 4, 1, 2, 3, 3 squared, 3 times 3 is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And of course, it's symmetrical, so I'll have a point here, and a point reflected over here. And then I'm just going to draw my parent function. Now, you need both, okay? We need both. We need to graph both, okay? 3, absolute value graph. Absolute value graph is the V. Okay, that's the parent function. But let's do this one first. The vertex of number 3. Let me go ahead and fold my paper. Okay, the vertex of number 3 is going to be, the vertex is at, remember, opposite. So it's -2, 1. Opposite, opposite, opposite inside. So I'm going to put down my XY axis. Again, if I'm going too fast, just pause it. Okay, pause it. You can do that. And then I'm going to take and go to -2, 1. That's my vertex. I'm going to have a slope of 1/2. So it's up 1 over 2, up 1 over 2. The other side. Okay, and then I get this absolute value graph. Looks like this. Now, the parent function is the regular old absolute value graph. So it's up 1 over 1, up 1 over 1, up 1 over, okay? Goes like that. Goes like that, okay? All right, number 4 is a square graph. We haven't done that one for a while. We only did it once, but the square graph looks like this. It's a sideways parabola. The points like are 1, 4, and 9, because the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, okay? So let's put that down. Okay, so let me put the parent function first, because it might be helpful if I put the parent function first, okay? So it's a sideways parabola because it's a square root. So I know that 1, 2, 3, 4, 5, 6, 7, 8, 9. And I like those numbers because, well, the square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Now there's other numbers in between, but those are decimal answers, like square root of 2 is about a 1.4, square root of 3 is about a 1.7, and square root of 5 is about 2.2, but you get the idea. Now, it does not exist over here, because you cannot take the square root of a negative number. Cannot. So the graph only exists here, okay? So now, what we're going to do with this one is we're going to take it down 1. Okay, so we're going to take this whole graph, we're going to go down 1. And then we're going to make it be flipped over the x-axis. And then we're going to make it twice as tall. So it's going to look like this. And again, you can, if you have any troubles with this, you can put it on Desmos 3, and I go 6. 1, 2, 3, 4, 5, 6. Okay? You can always graph it on Desmos or on a calculator. Okay? Now, 5. What is the domain and range? Well, what I should probably do is be easier if I just graph it, okay? A lot of graphing. So, let me real quickly just graph this one. Okay. So, I'm going to go ahead and just graph this one real quickly. All right. And I know the vertex, which is the opposite inside, so my vertex is at positive 3, negative 1, right there. It's a parabola because of the x squared, so it looks like that. It's a parabola, but it's half as tall, so it looks a little bit like this. 1/2 square root of, if I take 2 squared is 4, but half as tall. 2 times 2 is 4, but half as tall, so I get a 2. 3 squared is 9, but half of 9 is 4.5. 1, 2, 3, 4.5. I know it's symmetrical with this vertex, and so the graph looks something like this. All right, let me put the arrows on, that helps. Okay, now, domain. Well, how wide is this graph? Well, as these arrows go up, they're always going over. As this arrow goes up, it's always going over. So the domain is x equals all real numbers. Hold on, it's landing. Hey, I'm in the middle of recording. What's up real quick? Okay, bye. Okay, that was landed. And then domain, I'm sorry, range, because I got distracted. Range, sorry to make it so sloppy. Range, well, it starts at a height. It doesn't have anything down here. It starts at a height. Range is your y values of negative 1, and it goes up. Y is greater than or equal to negative 1. Okay? All right. Now, again, if I'm going too fast, just you can pause it. So write a function at g of x from a translation of fx. Okay, so we're going to take 6 and translate a 3 down. So what I'm going to do is just take a 3 down. So I'm just going to go and subtract 3. So my new function g of x would equal, you ready? Negative 4x minus 4. I just took it down 3, so I subtracted 3. Okay, translated to the left, opposite. So left 2 would mean to add 2 to the inside. And up 5, so I'm going to add 5. So let's see what I get. I'll get g of x, that's my new equation, is equal to, let's see, instead of x plus 1, I'm going to add 2 because opposite, so I'm going to have x plus 3 squared, and then negative 3 plus 5 is plus 2. All right, again, if I keep going too fast, slow me down. Okay, reflected over the x-axis, what happens is the y becomes negative. So f of x and y are the same thing. So I've got a negative y equals a 3x plus 4, right? Over the x-axis makes the y's negative. So let me bring the negative over. So let's call this g of x equals, you ready? Bring the negative over. Bring the negative over. I get a negative 3x. Bring the negative over, minus 4. Okay, there you go. All right, 9. We want to graph it. Let's graph it first, okay, and then we'll take a look at it, okay? So So let g of x, let g be a translation 2 units up and a vertical stretch of 1/2, followed by a horizontal shift of 5. And I want to take the absolute value graph, okay? All right, so the absolute value graph is the v, right? This is the absolute value graph. So let's take this thing and let's translate, okay? So if we graph it, since we have to graph it anyway, let's go ahead and start with a graph. And let me put that down. And again, if I go too fast, I'm sorry, but you guys can just pause it, right? Okay, so here's my original. Here's my absolute value of x. What I want to do is 2 units up, so let's take it 2 up. Vertical stretch of 1/2, followed by a horizontal shift to the left. 1, 2, 3, 4, 5. Okay. Now, if it's going to be, here's my new vertex. My vertex then is at -5, comma 2. So I'm going to have a g of x equals. And then half is tall. So it's going to, instead of up 1 over 1, it's going to be up 1 over 2, up 1 over 2, up 1 over 2, like that. Okay, there it is graphed. The equation is a 1/2 because of the stretch of 1/2. It's really kind of a shrink. Absolute value of x, opposite, 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 plus 5 plus 2. That's the equation, and there's the graph. The reason it's the opposite is because -5, plugged in for x, zeroes this out and brings you to your bottom point. That's why it's the opposite. Okay. 10. Find the equation of this linear function. Well, that's easy. It seems like, first of all, the slope, rise over run, looks like it's up 100 over 2. So m, I can just look at the graph, is up 100 over 2, or the slope is 50. And the y-intercept looks like 100, right? If you've got 150, 200, 250, 300, so it's at 100. So my equation would be y equals 50x plus 100. Now, what does slope represent in words? In words. Words. If you don't give me words, I'm going to count wrong. In words. Well, it really means, you ready? It means dollars per week. It means dollars, because that's how much it goes up. $100. It means $100 for every 2 weeks, or better yet, how about $50 per week? Okay, use words. Use words. Okay, all right, I'm getting there. Okay, 11. Okay, create a scatter plot. I can do that. Can I get my pen out and make an XY axis on my scatter plot? So let's put that down, and just like when we did the wave, scatter plot, scatter plot. I'm going to put number of lines down here. And I'm going to put cost here. I think I can go by ones. Yeah, I can go by ones. 1, 2, 3, 4, 5, 6, 7, 8. And cost goes all the way up to 39. So maybe I'll do a squishy. I might do a squishy. Squishy. And I'll start at 25. 1, 2, 3, 4, 5. I'll go 25. And then I'll go 30, 35, and I'll go 40. Okay? All right, so let me do my scatter plot. 427 is about there. It doesn't have to be perfect. 5 and 30 is about there. We've got 6 and 33 is about there. 7 and 36 is about there. 8 and 39 is about there. Okay, not a very good looking graph, but it's a scatter plot, right? So, okay, now either Desmos or calculator. I'm gonna use my phone. So let me go to, first of all, the one I like is this regression one. Hopefully you guys can see that. And I'm just going to type in my values, okay? In my regression, I'm just going to start with my table. I'm going to go 4 and 27, 5 and 5 and 30. I'm going to type in 6 and 33, add a point, add a point. I'm going to type in 7 and 36. I'm going to type in 8 and 39. Okay, done. And there's my scatter plot. Doesn't look too bad. It looks better than mine. A lot better than mine. Calculate. I want the linear regression. That's what we're looking for. Okay. So there it is. And the R value is 1. That's easy. Okay, that's nice. Find linear regression. So y equals a 3x plus 15. Correlation coefficient, R squared, is 1. Cost at 10 lines. Well, let's just use our formula. So I'll go 3 times 10 plus 15, which is 30, plus 15, which is $45. Okay. Using your equation, what would be the number of lines if the cost was 55? So set it equal to 55. I'm going to solve. Here we go. 55 equals my 3x plus 15. And we'll solve. Minus 15 minus 15. I get a 40 equals 3x. Divide by 3. What's 40 divided by 3? Well, it doesn't go in evenly. Okay, so 40 divided by 3. It's about 13 because we can't do half a line, so we're going to go 13.3, or we'll go 13 lines. About 13 lines. Okay, 12. Find the value of x and y. So to find the value of x and y on 12, I'll do it on a good piece of paper. I need room. Y equals 1 plus x and 2x plus y equals negative 2. I'm going to use substitution because that's just the way to go for me. Makes it easier for me. I'm going to substitute this 1 plus x in for y, put right there. So I'll rewrite this as 2x plus, not y, but what y is equal to. 1 plus x equals negative 2. Again, if I'm going too fast, pause it. I just don't want to do this all period, okay? 3x plus 1. 3x plus 1 equals negative 2. Minus 1 minus 1. 3x equals negative 3. Divide by 3. Divide by 3. X is negative 1. Okay, that's half the answer. It's negative 1 something. Take my negative 1 for x and plug it right there. So y is equal to 1 minus 1, or 0. Okay. Now, the big one. Number 13. Okay. And I'm probably going to make this as extra credit, so I will probably just go through it briefly with you. 3x plus 2y minus z equals 8. Equation 1, equation 2, negative 3x plus 4y plus 5z equals negative 14. And equation 3, x minus 3y plus 4z equals negative 14. Okay. Probably take equation 1, equation 2 together because I can cancel out the x's. Okay, equation 1, 3x plus 2y minus z equals 8. Negative 3x plus 4y plus 5z equals negative 14. Okay, pause anytime. I'm just trying to get this done on the tape. Okay, x's cancel. Gone. 6y plus 4z equals, what is that? 6, negative 6. Okay, make that equation 4. Okay, now let's pick 2 and 3 together because you got to pick 2 different ones. So I'll pick equation 2 and equation 3. I'll do that work over here. Okay, I'll do that over here. Equation 2, squeeze that in. Okay, so I've got equation 2 is a negative 3x plus a 4y plus 5z equals negative 14. And equation 3, I've got an x minus 3y plus a 4z equals negative 14. Oh, that's convenient, kind of convenient. Okay, now I need to make an equation like number 4. Got to. So I need to get rid of the x's. So just multiply this by 3, because that will cancel my x's. Rewrite equation 2. as is, negative 3x plus 4y plus 5z equals negative 14. Equation 3 changes to a 3x minus a 9y plus a 12z equals, I don't know, what's 14 times 3? Should be 42, I'll bet. 14 times 3, 14 times 3, 42. Yep. How about a negative 42? Okay, there you go. So when I add them, boom, boom, those are gone. I get a negative 5y plus a 17z equals, let's see, 6, 56, negative 56. Okay. Now that's an equation 5. Bring that over here. Okay, equation 5, I can line up. So equation 5 is going to be a negative 5y plus a 17z equals a negative 56. Okay, provided I haven't made a dumb mistake, so far so good. Multiply this one by 5 and this one by 6, and that'll make a 30 and a negative 30, okay? So equation 4, new equation 4, slide this over, is a 30y plus a 20z equals a negative 30. I'll get a negative 30y, 6 times 17, 102, plus a 102z equals 6 times 56, negative 56 times 6, probably a big number. Yeah, negative 336. You can see why I'm probably going to make this extra. Okay, so add these together, I get 122z equals, I don't know, negative 336. Divide by 122. Hey, I got an answer. Got a nice answer. Z is negative 3. Wow, that's a lot of work for that one. So then what do? Well, let's plug that probably right into here. Equation 4. Right there. Right? So I'm going to go, okay, 6y plus 4 times negative 3 equals negative 6. 6y minus 12 equals negative 6. Plus 12 plus 12. Plus 12 plus 12. I get 6 equals 6y. Divide by 6y equals 1. All right, I'm getting good numbers. I like it. Woohoo! So now I'm probably going to plug, I'll go all the way back up to equation 1, and I'm going to plug the y and the z in equation 1. Equation 1 is 3x plus 2y minus z equals 8. So then I'm going to go 3x plus 2 times what y is equal to, and y is equal to 1, minus z, but z is a negative 3 equals 8. 3x plus 2 plus 3 equals, plus minus, equals 8. 3x plus 5 equals 8. Minus 5 minus 5, 3x equals 3. X is 1. Got it. Whew. Finally. Okay, so the answer is 1, negative 3. Wow, that was hard. Okay, so I will probably make this the extra. So there it is.